So you are watching series one of Q Processor Mastery Program. Okay, and if you haven't subscribed to my channel, right? So please do subscribe to my channel so that you can't miss any sort of updates from the Pega. All right, yeah. So let's dig deep into this, Q Processor Mastery Program. Okay, of series one. Okay, so as we iterated in the introduction, web series, right? So I have said that I have iterated that I will be telling the introduction of this cube processor and why it has been introduced in the from 8 version of the Pega, and earlier what we used to have and why it has been deprecated, and what are the significances of this particular cube processor, and what are the few important aspects as well with respect to the interview questions. Okay, so these are all aspects we will be covering in this particular series one, and along with that few Kafka introduction as well. So let's open one of the Q processor available. Okay, so yeah. So as we know that, so this Q processor we will be creating from the it will be available from the sysadmin category. Okay, so if you just click this particular sysadmin and if you navigate to the Q processor, then you will be having few of the OTBs as well. Okay, so in interview, most of the interview questions, so the interview panel will be asking, so what are the few Q processor that you have been leveraged, right? So OOTB QPROS that you have been leveraged in your recent projects. Okay, so for this particular question, how we can answer these particular questions. Okay, I will be covering in the next series, means the next series number 2 or series number 3. I will be inculcating that particular series. Okay, so don't miss that series as well. All right, so at particular this series one, right? So I will not covering this particular thing. Why? Because I will be covering it overview. Okay, perfect. So this is nothing but few of the OTB Q processor are there. Perfect. So let me open one of the Q processor available. Q processors available at that we have created. Okay, earlier. Perfect. So yeah. So here earlier we used to have what standard agent. Okay, standard agent has been replaced by the Q processor. Okay, so as we know that standard agents, nothing but agents will be whatever the instances or whatever the there, right? So those will be stored under what directly it will be interacting with the database. Let me throw a quick example. You just ordered a food from the Swiggy of one of your restaurants, right? So what happened? So it will show a real time, right? I can say that real time streaming. I can say that navigation, right? Okay. So whenever the order has been picked from the particular restaurant, right? So the delivery executive will be navigating towards your journey. I mean towards your destination, right? So it is a what real time scenario. It's not like that every 5 minutes it will refresh. Okay, so streaming is nothing but it's nothing but a live, okay, I can say live platform. Okay, we can see that particular the journey. I can say we are interacting with the live streaming kind of thing. If we have used agents instead of queue processor, for suppose queue processor hasn't introduced yet, for suppose let's take an example, then we need to hit those instances with respect to the database, and we need to get back those updated instances from the database. Now just to think of, okay, for suppose in our area, let's take some I state something, high tech city, let's take an example. Okay, in high tech city, most probably there are huge crowded at there. Okay, as it's a cosmopolitan city, right? So let's take 1,000 members. Okay, for every thousand, right, for every second 1,000 members, for suppose they put an order on the Swiggy. Okay, now only particular high tech city area, okay, for second, for 1,000 people, if they are using that particular platform and they want the updated data from the database, now just think of this instance. Now just think of at Hyderabad level, think of at Telangana level, think of at India level, state level or India level. Now our server will be crashed. Now how can we handle all these things? It's not a good practice to handle with the database actually. Okay, that is the biggest limitations we have with the agents. How we can handle those? So that's why Pega has introduced one beautiful concepts called queue processor, wherein we can handle those instances as an asynchronous process by defaultly, and we can't able to depend more on the database now where those instances will be stored. So that is the biggest question over here. That's why Pega has introduced a Kafka integration into the Pega. Now what is meant by Kafka? Kafka is nothing but a streaming platform. Okay, it's an open source, but can integrate with the Kafka and they can leverage those particular thing. But suppose if you want to get the live data like ClickBus, like IPL, okay, now you can get those particular data from those particular thing, okay, without interacting with the database. Okay, so this is the biggest advantage with the Kafka, I can say. Okay, so that's why here what happened means not every instances will be stored under the database. Now only few of the instances will be stored under the Kafka. Now what are the few of the instances which are about to process those instances, like about to queue? So now those instances will be stored under Kafka. Remaining whatever the broken items are there, whatever the delayed items are there, and whatever the stream node downs are there, so those instances will be stored under the database. So that's why Kafka is a we can say it acts like a asynchronous processing by default, and we can say that it's a fast processing, right? Because see here we queue processor is built for what, to maintain low throughput and as well as a high throughput simultaneously. For low throughput we will be having some another queue processor we have, that is nothing but standard queue processor, and for in order to handle the high throughput we can have a dedicated queue processor. Why it has been termed it as a fast processing? Why? Because first, number one, we are not dealing with the database, we are dealing with the Kafka. Now Kafka, it act as a intermediate between source and as well as a we can say, for suppose we will be having a producer and as well as we will be having a consumer. Let's take an example. Restaurant is nothing but producer, I can say. Okay, let's take an instance, I can say. Okay, restaurant is a producer and you is not, and you are nothing but what, who consume this particular data. Okay, now what happened means if we use this particular Kafka as a streaming service, okay, Kafka as a intermediate between these two. Okay, now what happened means, so for every request, right, for every request it hits to the database, it hits to the Kafka. Okay, now it bring back those instances from the Kafka to the your destination, I can say. Okay, it acting as a intermediate, so that we are not directly interacting with the database. So here the database interactions is limited. Okay, very 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 limited. Okay, directly we are interacting with the Kafka only. Okay, so is Kafka is nothing but it's like a streaming platform who listens to the particular request, and who delivers to the particular to that particular destination. That's it. Okay, so this acts as an intermediate, I can say. Okay, so in into that particular thing, right, it has many partitions kind of thing. Okay, so that partitions is as compared to the Pega, right? So as we are dealing with the Pega, so there are few I can say restrictions about the partitions. Okay, so during 8 dot up to 8.7, right? So we had 20 partitions. Okay, we had 20 partitions as a default one. Okay, but from 8.7, right? So the default partition has been decreased to 6 only. Okay, earlier we used to have 20 partitions, but from 8.7 we will be having only 6 partitions. Okay, the partition count is 0. Okay, means it's an ordered list kind of thing, means from 0, 1, 2, 3, 4, 5, like that it will be having. Total 6 partitions are there. To store any particular data, obviously we need some ID kind of thing. So here, for suppose, let me take an example. Okay, so I think I already opened one of the, we have. Okay, so let me take, this is nothing but our Pega, PRPC person edition directory. Or if I double click on that, I will be having this Tomcat server. Okay, Tomcat directory. And if I double click on this, I will be getting this Kafka data. Okay, so if I just double click on this, so these are in nothing but this I can say a few of the OTBs are there, and few of the we have customized that thing, right? So we have done all these things. Okay, so if you just observe, we will be having 0 to 5, 0 to 5, 0 to 5 are there. Okay, that is nothing but it's nothing but ordered kind of thing, ordered list, I can say. Okay, the index just you can observe, it has been incremented up to 5. Okay, 0 to 5. Okay, that is nothing but 6 partitions are there. So here whatever the ready to process queue instances are there, right? So it has been stored under here. Okay, nothing but it acts like a, now what, it acts like a database, I can say. Okay, now for suppose you are a producer. Now what happened means, for suppose I am a consumer right now. For suppose I send a request via I can say via Swiggy app. Okay, now what happened means, directly I will send a request to you. Okay, now Kafka, it acting as a intermediate. Now Kafka, what it does means, Now from the producer, it bring back those instances and gives to me. That's it. Okay. So that what happened means whatever the database interaction is there, right? It's completely null. Now you might be having a question for suppose if I want to query the item, if I want to bring back those item so that I can be using in the report definition or somewhere else. If I want to query those records, query those instances, then how can I do? From the Kafka, we can't able to do any sort of querying operation. Let's select star from the table or so and so, bring back those instances, and I can once I get all those instances onto the page, then I can be doing number of operations, right? No, I can't do any thought, any sort of the query operations from the Kafka. Now, how can I do? How can I handle all these things? So for this particular thing, so what happened means, so we will be storing those instances in the database so that when we need those instances from the database, we can query it. That's it. Okay, as we know that Kafka, it's like a short-lived kind of thing. Okay, it's like a short-lived kind of thing, and we need to handle those in as a cautious, I think. Okay, so now we need to handle with care, and we need to take care of those instances as well. It's like a database, I can say. Here, we are not storing, or we are not saving, or we are not interacting the database for every second, like for streaming purpose. So here, if you want to store those particular data, right, to store the permanently, obviously we need some database table. Okay, so we are not saving those database instances kind of thing directly to the database for every second. We will be running few jobs, like scheduled jobs, I can say, like daily ones or half day ones, like that, from quarter ones, like that we can do. So that here what happens, database interaction is truly limited. So with these aspects, we can say that this can be handled even for the low throughput and as well as a high throughput. Throughput is nothing but what? The requests, I can say, the messages, I can say, the incoming message, the outgoing messages, what we are dealing with. The instances, I can say, the queuing instances, the queuing items, we can say, the queuing records, we can say. How fast you are delivering, how fast you are consuming, how fast you are producing, how fast you are interacting with the Kafka. These are nothing but throughput, I can say. Okay, like I can say the strike rate, if we are talking about this IPL, the strike rate, I can say, the economy, I can say. Okay, so these are the few generic aspects, I can say, which will be covering, which will be comparing with this particular throughput, I can say. Okay, so with this, I can also strongly agree that it's a high throughput. Along with that, okay, it's like a fast processing. Why fast processing? Why? Because here there is no interaction of the database. Here directly we are directly interacting with the Kafka. That is the process. That's why Q processor is a fast processing. Okay, so this is a simple statement only, but behind that there is a big story. Okay, there is a big backstory, I can say. Okay, so these are the aspects which you need to understand actually. So these are the few partitions. Treat it like a database. Okay, so you can't able to if you delete, that's it. Okay, and one more thing. For suppose if you want to edit some sort of data, for suppose in database, if you want to modify any sort of property, okay, you can do by running the query. But in the Kafka, once you save those instances into the Kafka directory, okay, you can't able to modify, you can't able to edit, you can't able to customize, you can't able to override. But yes, you can add more instances. Yes, you have the privilege to add more partitions. Yes, you have the privilege to add more instances to the particular directory. Okay, you can delete, you can add, you can I can say, do whatever, but addition, edit or customization is not possible. Okay, so it's like a I can say immutable kind of thing. Okay, we can't edit. Okay, yeah, perfect. And the other thing is that, as we can say, it's like an incremental, right? So from 0 to 5. Okay, so for suppose if I want to store my instances like in a sequential manner. in a sequential manner. Or else if I want to store my instances at the third partition or fourth partition explicitly, I don't want to let Pega, does this job. Okay, now how can we do? For suppose in Kafka, so we will be having a concept called key. Okay, for suppose if that instance has a key, if that instance has a key, that is nothing but message I can say. If the message has a key, if the message has a key, then we can develop a few functions to store a particular desired table, desired topic, we can say. For suppose if you are storing, if you want to store at the some fourth partition, okay, then you get that particular unique id, okay, and you write some sort of functions, okay, and then you can store those instances into the particular fourth processor, I mean fourth partition. Okay, so this is one type of fashion we can say. For suppose if you don't have any sort of key to handle these particular instances, like in order to meet these instances, no, okay, it is not possible. If you don't have any, if you don't even have any sort of key for the each and every messages, then it Pega what it does means, I mean Kafka what it does means, it's like an internal mechanism. Okay, it will store, okay, it will store in a sequential manner. For suppose first it will go to the 0, second it will comes to the 1, second, and next it will comes to the second, third, fourth, like on it keep on performing round robin kind of thing. Okay, once it complete, then jumps back to the first, then jumps back to the second, like that it will perform a round robin kind of thing. Okay, so here we need to understand in two aspects. One, if you have a key, then you can save those instances with particular I can say particular partition. If you don't have any sort of key, then obviously no Kafka does its job, okay, internally. Okay, like by performing round robin kind of thing. Okay, so these are about few of the Kafka introduction. Okay, so if you want to learn more about the Kafka, right, so there are a beautiful articles has been published by the Pega. All right, so this is all about few aspects, few respect to the Kafka. So once again I am reiterating that Kafka, it's like a database I can say. Okay, so we are whatever the item process are there, right, so whatever gonna process, right, so those instances only will be sharing in the Kafka directory. Okay, from that Kafka directory only the streaming platform, the streaming services will be executed. Okay, so remaining other than this, the process or processing the records are there, right, so remaining all those instances will be stored under the database. Okay, and the second aspect is that Kafka is a temporary storage kind of thing. If you want to storage in a permanent way, then you need to commit to the database. If you want to query some particular thing, if you want to maintain some analytics kind of thing, then you can have with the database kind of thing by performing few periodical or scheduled tasks, scheduled jobs, I can say. Okay, so this all about few of the aspects which relates to the topics called introduction of the queue processor, and as well as this as well. All right, this Kafka. Okay, now just compare with the standard agent. How Pega has thought, like I can say that's a revolutionary thought I can say. Okay, for the standard agent, we don't have any sort of all this kind of thing like partitions kind of thing, asynchronous behave kind of thing. Directly we are introducing, directly we are gathering, directly we are I can say hitting with the database, and we are bringing back those instances into our UI or what it may be. Okay, so that's why Pega has thought of these aspects, and it has been introduced to this thing. Okay, hope you got a brief idea on the Kafka, and as well as the why Pega has introduced this particular queue processor as well. All right, yeah, so meet you in the second series. Okay, so don't miss. Chalo, bye, take care.